Hello, Chemistry 30. This is our first lesson in the Organic Chemistry unit. This is Introduction to Organic Chemistry. In this lesson, we will explore organic chemistry and the carbon atom, isomers, structural diagrams, alkanes, how to name and draw alkanes, and we'll work through two examples. Organic chemistry is the study of molecular compounds that are based on carbon. It is commonly said that these molecules have a carbon backbone, which can be observed in this picture. Hydrocarbons are composed of carbon and hydrogen. Exceptions are inorganic compounds which contain carbon. Examples include oxides, CO2 gas, ionic compounds like cyanide or carbonate, and non-organic acids which typically contain a polyatomic ion. All of these examples are not considered organic molecules. They are considered inorganic. The carbon atom is very special. It contains 4 bonding electrons, which can be observed here. Therefore, it will always form 4 bonds. There is an infinite amount of hydrogen in the universe which will combine to carbon atoms. For example, if we look at this molecule, each one of these carbon atoms contains 4 bonds. What's also unique is carbon can form single, double, and triple bonds with itself, as observed below. Notice still how every single carbon has 4 bonds attached to it, regardless if it's a double or triple. There are still 4 bonds attached to every carbon. Structural diagrams are a way to represent organic molecules. The first diagram is a complete structural. It shows every single bond in the molecule and is represented by this picture. The next is a condensed structural diagram, which only shows the carbon-carbon bonds. Looking at this picture, we can see that only the carbon-carbon bonds are shown. There are still bonds between the carbon and the hydrogen atoms, but they are not represented. Next is a line structural diagram. Carbons are represented at the end of each line. If we look at the picture, carbons are located here, 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 and here, at the end of each line. The last 2 structural diagrams are rarely used, but sometimes show up on diploma exams. Next is a ball and stick. This simply represents each atom by a sphere. The black represents carbon, and the white represents hydrogen. This is more of a realistic structural diagram because it shows the proper orientation of each atom around another. And finally, space-filling diagrams show the electron clouds around each atom. If we look at our first picture, we have 1, 2, 3, 4 carbon atoms. This molecule is called butane. If we look at our last picture, we only have 1, 2, 3 carbon atoms. This molecule is known as propane. It's important to note when naming organic molecules, we only consider the carbon atoms. Hydrogen has nothing to do with the nomenclature. Isomers are compounds with the same chemical formula but different structural arrangements, meaning they will have different names. These three molecules are examples of isomers. Each one of these molecules has 6 carbons and 14 hydrogens, therefore the same chemical formula, but each has a different name. Therefore, they have a different structural arrangement and are considered isomers. Organic classification. There are 3 major classifications of organic molecules. First is alphatics, and this will be the focus in the first 3 lessons. Alkanes, alkenes, and alkynes are all examples of alphatics. Each of these molecules only contains carbon and hydrogen. Aromatics is our next classification, and it contains benzene structures. And finally, hydrocarbon derivatives is the last classification. This contains any functional group, for example, halides, alcohols, carboxylic acids, and esters. Organic nomenclature. Every organic name follows the similar pattern of a prefix plus a root plus a suffix. The prefix indicates the name of the branches and their location on the main carbon chain, which is also commonly known as the parent carbon chain. The root indicates the number of carbon atoms in the main carbon chain, and the suffix indicates the type of compound. For example, in today's lesson, we will only focus on alkanes. Therefore, the suffix of every molecule will end in -ane. Organic prefixes, also used for the root. A 1-carbon chain is given the prefix meth, and methane represents a single carbon alkane. A 2-carbon chain is given the prefix eth. 3 carbons is pro. 4 carbons is bu, example butane. 5 carbons is pent. 6 is hex. 7 is hept. 8 is oct. 9 is none. And 10 is dec. Do not worry about memorizing these prefixes. After practicing nomenclature, this will be very simple. Alkanes are hydrocarbons that contain only single bonds and only have carbon and hydrogen atoms. They are considered saturated hydrocarbons because they have the maximum amount of single bonds between carbons. The illustration below represents an alkane because the bond between each carbon is a single bond. If you are trying to determine the number of hydrogens in a molecule which is an alkane, you can use the following formula. For example, if there are 6 carbons in the chain, N will equal 6. H will then be 2 times 6 plus 2. As a result, the chemical formula is C6H14. This is also known as hexane because there is a 6-carbon chain. You can also just combine each one of the carbons by a single bond. And remember, every carbon gets 4 bonds. By simply adding the remaining bonds to hydrogen atoms, you can still determine that the number of hydrogens would be 14. Branched chains. A branch is a group of atoms that is not part of the main carbon chain. The prefix indicates the branches on larger molecules. The prefix is followed by the YL ending, which tells us this is an alkyl branch. Alkyl branches consist of only carbons and hydrogen atoms. For example, if we look at the picture below, this is the longest carbon chain. When counting a carbon chain, we cannot count the same carbon twice. So we have 1, 2, 3, 4, 5, 6, 7. We cannot count 1, 2, 3, 4 because we've counted the same carbon twice. This is a 7-carbon chain, also known as heptane. The carbon above is then a branch because it's not part of the longest carbon chain. This is a 1-carbon branch, which we would name as methyl. Meth because it's a single carbon with a YL ending telling us it's a branch. It's important to note that you do not number branches on the first carbon of the parent chain, and that is because they would no longer be considered a branch. They would be part of the longest carbon chain. Carbon chains do not have to be straight. They can go up, down, to the side, as long as you don't have to count the same carbon twice. Naming alkanes. Number 1, identify the longest continuous carbon chain. This will be your root. Remember, the chain does not have to be straight. Number 2, identify any carbon branches. Then number the main carbon chain from the end that gives all branches the lowest total possible numbers. Number 3, identify the location of any branches and use the number of carbons in each branch to name it. If you have multiple of the same branch on a molecule, you can use di-tri. For example, trimethyl tells us we have 3 single carbon branches. And remember to name branches in alphabetical order. For example, ethyl comes before methyl. When naming alphabetically, ignore any prefixes, for example, di or tri. And then finally, write the complete compound name, which is the prefix, the branches, followed by the root, the longest carbon chain, followed by the suffix, the type of organic compound. Consider the following. Organic nomenclature is very specific. There are no spaces between organic compounds unless otherwise stated. For example, 2-methylpropane has no spaces in the name. Dashes go between numbers and letters. For example, 2-methyl. And commas go between numbers. For example, 2,3 dimethyl. Example number 1. Name the following structural diagrams. Pause the video and attempt this example. In our first structural diagram, we first have to find the longest carbon chain, which is 1, 2, 3, 4, 5, 6. We then want to number that carbon chain from the end that gives all branches the lowest value. And we would want to number it from left to right. That gives this branch a 2 value and this branch a 3 value. If we numbered it in the opposite direction, the numbers would be larger. We then have 2 branches. This branch has 1 carbon. It is a methyl branch. And this branch has 2 carbons. It is an ethyl branch. Our name is 3-ethyl-2-methyl hexane. 3-ethyl because there's a 2 carbon branch coming off the 3rd carbon in the chain. -2-methyl because there's a single carbon branch coming off the 2nd carbon in the chain. Hex because the longest carbon chain is 6, and an ANE ending because every bond is a single bond in the structure. In our next diagram, we'll circle the longest carbon chain. Remember, it does not have to be straight. We have 1, 2, 3, 4, 5, 6 carbons, again, in our longest carbon chain. And we'll number it from the side that gives all branches the lowest value. Again, numbering it from left to right gives the 2 branches here a 2, 3 value, which would be the lowest possible. We have 2 branches. Both are a single carbon branch. Therefore, our name is 2,3-dimethyl hexane. 2,3-dimethyl, meaning there are 2 single carbon branches, one coming off the 2nd and one coming off the 3rd in the longest carbon chain. Hexane, because our longest carbon chain is 6 and all bonds are single bonds. Again, remember, dashes go between numbers and letters, and commas go between numbers. There are no spaces in the 2 names. Drawing alkanes. This is much easier, and it's important to note that not everyone's drawing will look the exact same, but they could all be correct. You may just be drawing that molecule from a different perspective. When drawing, always start from the back of the chemical name. That is the longest carbon chain. Draw your carbons first, then add the hydrogen atoms. And remember, it doesn't matter what end you start numbering your parent chain from, because you may be looking at it from a different perspective. Example number 2. Draw the condensed structural diagram for 2,3,4-trimethylpentane, and then draw the line structural diagram for 2,2,3,3-tetramethylbutane. Pause the video and attempt this example. Remember, a condensed structural diagram only shows the carbon-carbon bonds. And our structural diagram is represented here. So remember, start from the back of the name, and that is pentane, a 5 carbon chain. 1, 2, 3, 4, 5. Then trimethyl. That tells us we have 3 single carbon branches, one coming off the second, third, and fourth. If we consider this our first carbon, here's our second, our first methyl branch, our third, our second methyl branch, and there is our fourth, our third methyl branch. And then you can simply add in all of the hydrogens. Remember, each carbon needs 4 bonds. So if I look at this carbon right here, it already has 1, 2, 3 bonds. So it only needs 1 more bond, 1 hydrogen. Or if I look at the last carbon right here, it only has 1 bond. So it needs 3 more bonds. It needs 3 hydrogens. And our last structural diagram is a line structural diagram. And it is represented by the picture here. Remember, start from the back. Butane, that's 4 carbons. 1, 2, 3, 4. At the end of every line is a carbon. Then we have tetramethyl. That tells us there's 4 single carbon branches. 2 of those branches are coming off the second carbon, and 2 of those branches are coming off the third carbon. If we consider this our first carbon, here's our second. There's 1 methyl branch and the other. This would be our third carbon, and here is the remaining 2 methyl branches. Moving forward, we will look at cycloalkanes.